Hello viewers, in today's session we are going to discuss a very conceptual and important problem from definite integrals, right? So here in this class we are going to evaluate this integral that is from 0 to 2, and here we have 4 minus x square raised to 3 by 2. So let us start. So here we are going to use the method of substitution, and let us call this integral as I, right? So we'll substitute here. X square is equal to 4 times t, where t is our new variable. Now x can be written as square root of 4 times t, and x is equal to 2 times square root of t. So basically we are going to substitute x is equal to 2 times square root of t, and t is our new variable. So let us differentiate x with respect to t. So dx over dt is equal to 2 times the derivative of square root of t, right? And the derivative of square root of t with respect to t is 1 over 2 times square root of t. 2 and 2 get cancelled, and we have 1 over square root of t. So now a dx can be written as dt over square root of t, and let us change the limits accordingly. So here x varies from 0 to 2. So when x is 0, then the value of t can be obtained from this relation, right? So t is x square over 4. So when x is 0, we have 0 square over 4, that is 0. And when x is 2, which is the upper limit, so t is 2 square over 4, that is 4 over 4, that is 1, right? So now let us transform this integral I in terms of t. So now we have I is equal to, the limits vary from 0 to 1, and here we have 4 minus x square is 4 times t, and here we have 3 by 2, the power is 3 by 2, and dx is dt over square root of t. Now let us simplify this integrand. So we have 0 to 1. We can take 4 common from these two terms. So we have 4 raised to 3 by 2, 1 minus t raised to 3 by 2, and here we have dt over t raised to half, right? So now we can write I is equal to 4 raised to 3 by 2 is given by 4 cube raised to half. So this is 64 raised to half, that is 8 square raised to half. 2 and 2 get cancelled, so we are left with 8. So here we can write 8, and taking 8 outside the integral, we have 0 to 1, and we can take t raised to half to the numerator. So we have t raised to minus half, and here we have 1 minus t raised to 3 by 2 dt, right? Okay, now let us rewrite this integral as 0 to 1. T raised to minus half can be written as t raised to half minus 1, and here we have 1 minus t raised to 5 by 2 minus 1, and here we have dt, right? So now we have converted this integral into the beta function. So now from the definition of beta function, we know that beta m comma n is given by 0 to 1, and here we have t raised to m minus 1, 1 minus t raised to n minus 1 dt. So this is the famous Euler's integral, which is also known as the beta function, and here m and n are greater than 0, right? So we can now write this integral as 8 times here we have beta of half comma 5 by 2. So the value of m is given by half and the value of n is given by 5 by 2, right? So now we have this integral I as 8 times beta half comma 5 by 2, right? Now we can convert this beta function in terms of gamma function, and we know that beta m comma n is given by gamma m times gamma n divided by gamma of m plus n, right? So this integral I is now 8 times gamma of half. Here we have gamma of 5 by 2 because m is half and n is the 5 over 2, and here we have gamma of half plus 5 by 2, right? Okay, now we know that gamma of half is given by square root of pi, and gamma 5 by 2 can be written as 3 by 2 plus 1, and which can be written as 3 by 2 times gamma of 3 by 2, and here we have 3 by 2. Gamma 3 by 2 can be written as half plus 1, so this is 3 by 2 times half, and here we have gamma of half, right? So this is 3 by 2 times half times square root of pi, because gamma half is square root of pi. So here to get the value of gamma of 5 by 2 as 3 by 2 times half times square root of pi, we have used here the result, that is gamma n plus 1 can be written as n times gamma of n, right? So now our integral I takes the form, we have 8 times gamma of half is square root of pi, and gamma of 5 by 2 is 3 by 2 times half times square root of pi, and in the denominator we have gamma of half plus 5 by 2, which is 1 plus 5 over 2. This is gamma of 6 over 2. This is gamma of 3, and we know that gamma n plus 1 is given by n factorial, where n is some positive integer, right? So here gamma 3 can be written as gamma of 2 plus 1, which is equal to 2 factorial, that is equal to 2 times 1, that is 2, right? So here we have 2. So now we have 8 times square root of pi times square root of pi is pi. Here we have 3 over 4, and here we have 2, so we can write it as 1 over 2. So 4 times 2 is 8, so here 8 and 8 get cancelled, and we are left with only 3 times of pi, right? So viewers, the value of this integral is given by 3 times pi. So this is how, by making use of the concept of beta gamma functions, we can evaluate these kind of integrals.